Welcome to Will 5G revolutionize the manufacturing industry, and what hurdles do we still need to overcome? I'm Catherine Speglia, and I'm the managing editor at RCR Wireless News, and I'm joined by Abellatif Benjelloun from Digital Catapult, Steve Brown from Inseego, Asimakis Kokkos from MFA, and Andreas Mueller from Bosch. Let's jump right in with my first question. That's for Abellatif. Digital Catapult is coordinating the industrial 5G test beds and trials program in the UK. Drawing from the company's experience demonstrating the value of 5G beyond mobile broadband, what new or improved manufacturing use cases are on the horizon?
Well, thank you, Catherine, for this question. And let me first give an overview about the industrial 5G test bed and trial program that is run and funded by the DCMS, the UK Government Department of Digital. So this is a program of 8 projects tackling 5G early deployment within the manufacturing and logistics sectors. And the projects are dealing with the number of use cases that deals with the whole challenge across the whole segment of industrial 5G value chains, from the design side, production, operation, including also logistics to the maintenance. So across all these value chain, we have the projects are tackling a number of use cases, and we have noticed that they are sharing a lot of commonalities. So this is why we have done some clustering into major categories according first to the 5G features they use, and also the manufacturing challenges that they are kind of addressing in specific segments of the industrial value chain. So you have mentioned mainly the 5G enhanced mobile broadband. So this is the first, let's say, characteristics or feature of 5G. And here we have a big category about AR, VR, and mixed reality. And just to give an example of use cases here is about using AR for instruction for training. But we have a number of other categories of use cases. I would say that one of the major one of them is about automation use cases. So automation use cases, be it in the factory or for the processes, this is a big part of the use cases within manufacturing. And they are mainly based on the concept of closed loop control. So to automating robots, you need some control that should be put, for example, in the cloud or external to the robot, the famous PLCs. And here 5G is very important to bring its low latency and reliable or ultra reliable communications features. So without these features, these kind of use cases cannot work. And we see sometimes that you need a latency that is less than 10 milliseconds. So we have projects like 5G Factory, which is Factory of the Future, tackling a use case of Factory of Future. They are implementing use cases where you have sensors on the machine and collecting the data with closed loop control. So this is one big category. Another big category is about digital twins. Digital twins, as you may know, is mainly about duplicating the physical world in the digital world. And here you need some communication between these two worlds. So you need high data rate, you need low latency, and you need also to collect the ability to handle vast amount of data. Because all this data will go to the digital world. There will be some artificial intelligence or intelligence implementing decisions that come back to the physical world. So again, here we have seen a lot of use cases about data-driven digital twins. And one of them is used to throw the whole product life cycle in the manufacturing. And we have seen a good result of improvement, like 20% of improvement in machine utilizations and factory efficiency. So this is also one of the major categories. You have the classic one about predictive maintenance, but you have also one that people don't think about it or generally don't talk about it, is about asset tracking. Because we forget that 5G can give you kind of high accuracy in the factory floor. And this can be used for assets tracking and monitoring, which can bring significant financial and quality improvement benefits for the manufacturing facility. So this is kind of the big categories that we have noticed through our industrial 5G testbed and trial program, through all the projects. We have, I don't remember the number of use cases, but more than 30 use cases. And there is a rich information that we have learned there about the technical needs from 5G, the constraints, etc. But also there is a very interesting lesson that we have learned, that you cannot learn about or understand what 5G can bring unless you go to the ground with the OT industry and having this relationship or a partnership between the ICT, the vendors, the telco operators, to examine the use case and see how can 5G facilitate and enable new solutions using other digital technologies like artificial intelligence, AR, VR, and all of that, in order to increase productivity, efficiency, sustainability, and resilience across the whole manufacturing value chain. So this is, in a nutshell, my addition here to your point about the use cases that will come in the future and how 5G will tackle them.
Okay, thank you. And actually, thank you for sharing that 5G learnings, because I am going to kind of continue on that thread and ask Andreas about what Bosch is up to, because Bosch began operations at its first 5G campus located in Germany, but that was just the first step, because the company intends to roll out 5G at its roughly 250 campuses and plants around the world. So Andreas, can you share with us some of the early learnings or key takeaways the company has discovered so far when it comes to deploying 5G in a manufacturing environment?
Yeah, sure. Thanks, Catherine, and also thanks for having me as part of the panel today. Actually, it was not even the first step, right? We started looking into 5G already a couple of years ago. I think the first research activity started around 2015, so that's really 6 years ago already. We were collaborating at a time with some partners from the telco industry, working on early prototypes and demonstrators to explore the potential of 5G, even before the standard has been finalized, basically. And then we also did some 4G tests in some of our plants. So we installed a private 4G network in 2018. To get some first hands-on experience with mobile communications. And at that time, 2018, we also then were one of the driving companies behind 5G ACIA, the 5G Alliance for Connected Industries and Automation, which is a global forum for bringing all relevant stakeholders related to 5G manufacturing together. And I still have the pleasure to act also as the general chair of 5G ACIA today. So the trial that you mentioned, this is basically the first, let's say, real trial based on commercial equipment in a plant in Germany. So it was about a year ago. We deployed a campus network in our Industry 4.0 Lighthouse factory in Stuttgart. Basically, in the background, you can see a picture of what it looks like in the factory. Of course, you cannot see really the critical parts here. But we built this up, a Release 15 network, 5G standalone, in order to explore what 5G can really do and offer in a real-world production environment. As Abellatif also mentioned, it's really important to look at a concrete deployment and a real-world production facility. But it's just one out of several trials that we are currently having. So we are testing 5G in about 15 locations worldwide, looking into different types of production. Semiconductor manufacturing is very different from the production of household appliances, for example. Here in Stuttgart, we are producing pumps for engines. So we are looking into different types of production, and we are also evaluating then different deployment and operating models. We are collaborating with different partners in order to really get a good understanding of the capabilities of 5G in real world, but also of the different offerings and different technical solutions that exist. So we are still in the trial stage. That means the major goal is to validate the performance that we can achieve in real world. Nobody has really done that before. I mean, others are doing it also, of course, but basically the standard has been finalized first before you can perform such tests, of course, and just relying on some simulation results certainly is not enough if you are running production critical applications later over the system. So therefore, checking now what data rate can we get, how reliable is it in real world, and so on is really key. We want to understand the opportunities that 5G can offer, but also the limitations. But it's not just for our own trials, for our own plants that we are testing this. Bosch, of course, is also a major vendor of components and solutions for industrial automation. So we're also using this as a test bed, basically, to develop early prototypes and demonstrators and so on for our own products, which will integrate 5G in future, like automated guided vehicles, industrial robots, and so on. And also, apart from the performance validation, there's one thing that is also always key. This is the integration of a private 5G network into the enterprise IT infrastructure. Of course, it's very security critical, very sensitive production data, and so on. So therefore, you want to have this highly secure. At the same time, you want to have a smooth integration that you can really also exploit the full potential that 5G can offer. And integrating this in a secure manner along with the security architectures and so on that we have today is really a challenge on its own. Now, what were the key learnings so far? I mentioned this already. We are testing with release 15. Of course, this is the only standard that is available today in commercial solutions. But of course, release 15 does not offer the full or cannot deliver on the full promise of 5G yet. So especially for industrial applications, also here, Abellatif mentioned this before, we need, in many cases, low latencies, we need real-time support, we need a very high reliability. So release 15 can only support this to some extent. So it will get more interesting than with release 16 and the future releases. We also noticed that it's not really plug and play yet in most cases. So just connecting a simple 5G module to the network is something that kept us busy for I would say even 1 or 2 weeks. So it sounds very simple, but we noticed it's at the end, at least today, still more complex, of course, than other systems like Wi-Fi and so on. And there's certainly potential to make this even smoother and to increase the ease of use. The enterprise IT integration, I mentioned this already. So to bring this together, the security architecture from the 3GPP world with the security architectures from the industrial automation world. But we also noticed that there are quite some differences in the different sites where we are evaluating 5G. So in some deployments, we have, for example, always a very excellent performance, always the highest modulation encoding scheme. So basically the way you would expect it and want it. Whereas in other sites, it's basically very fluctuating, the performance that you can achieve depending on the location and so on. And of course, this is not so obvious immediately why this is like this, and it's also something we are trying to understand, right? So really to see, is this a matter of the deployment? Is this a matter maybe of the different infrastructure equipment that they're using, and so on? So there can be many different reasons. Is it just poorly configured? But that's where we basically are. So we want to understand this. We want to build up know-how. We want to gain experience, and so to really come up with a good strategy. Then, if we want to scale up, as you mentioned, to not just the 15 plants where we're using it today, but more of the Bosch plants worldwide. And maybe a last comment to make. So also what we observed so far is that, of course, there's still, we don't have a solid ecosystem yet of devices. Having a 5G network is one thing, but you also need all the end devices that you can connect to the network in order to make something useful and meaningful with it. So I'm thinking about automated guided vehicles, about robots and so on, AR headsets. So all this does not really exist yet with 5G connectivity. So we are still at the beginning of this development. But we expect, of course, that this will now ramp up in the months and years to come. And we also noticed that the current offerings are still a bit expensive, I would say, in many cases. So the vendors are approaching this maybe from the top end, what they would like to get out of this. But for a manufacturer at the end of the day, the only thing that matters is really the return on invest. And you don't want to wait 8 years until you get the return on invest. And that's something where we still have to find a sweet spot so that it's really attractive enough for all stakeholders in the ecosystem. But in general, we see a lot of good developments, especially around these private 5G networks. And that's, of course, what we are very much looking into, that we have our own private networks, which are somehow decoupled from the public networks. Also here, there are different flavors, of course, for doing this, different operating models. And we are also building up still our know-how, what the best option would be. But what we see is now that the fact that it is possible to deploy private networks really triggers a lot of innovation. There are new players coming up. There's a lot of activities in the startup community with tailored offerings. And that's really interesting to see. And of course, very beneficial for a big end user like Bosch, because suddenly there is not only one or two options that you can choose from, but there are many more vendors coming up, offering tailored solutions for manufacturing in other areas. And I think that's really great to see and very beneficial from our point of view. And with that, maybe I'll give it back to you, Catherine. Thanks.
Thank you so much for that answer. And now, Makis, even within the manufacturing vertical, it can be safe to say that each customer will have different requirements and networking needs depending on several characteristics, including things like campus size and location and product specifications. As a result, service providers need to find a commonality between the 5G use cases, some of which we've discussed today, to better serve industry verticals. How does spectrum liberalization fit into this conversation of offering bespoke networking solutions, but also simplifying the go-to-market strategy for providers?
Absolutely. Great question, Catherine. Thank you very much for having me today in the panel. So yeah, it is true that we have so many different environments, so much diversity in the industrial and vertical cases, from let's say from ports, airports, mines, logistics, whatever you can imagine. So I think it's safe to say that one size does not fit all. And that is the case when you try to offer, let's say, the 5G in the traditional way, like you have normally a public offering network that can put some macro base stations and try to provide the services which are very, very demanding. And the customers, the enterprise customers, they really need to have such a good coverage and data rate and latency and all that. So it is kind of very difficult if you imagine that only with a few base stations outside a premise or something you can really make it. So what do you need? You need really coverage in premise. You need some kind of very careful radio planning that is tailor-made to some, let's say, factories or areas. And in that case, what is needed is that you also have better optimization. And for that reason, the locally licensed spectrum is coming to play a role. So you need to have the whole area, like the factory that you're talking about, which is dedicated spectrum. So you don't need to interfere with the public network. And if a public network, for example, has an outage, it wouldn't really interfere in your case to whatever you have in the factory. You can also really plan much more carefully so you don't have any gray spots that could really create a lot of, let's say, gaps that will affect quite your production lines or whatever. So that is the model now that it's also planned in some countries, like in Germany. We have the 3.7 gigahertz band, in the UK from 3.8 to 4.2. I think it's a big spectrum chunk, and also the 26 gigahertz, and also like in US the CBRS example and others in other countries. So it is becoming clear that this locally licensed spectrum is very important. And it is not something to say that it will substitute the current model that one has in mind with the normal, let's say, MNO no case, but it will enhance it. It will be a more complementing. So you could have opportunities for new players that you could really offer private networks which are really meeting the demand, what you want to achieve, but also you will have the MNOs themselves. They can offer it as well by making a separation of a private and the public network, so that it will make sure that there is no interference, or the network works fine in both cases. So the locally licensed spectrum and a very simple regime that would really make it happen. It would be an enabler. It will play a role. Now, If we add on this the unlicensed spectrum, which is already here, and we have like in the 5 gigahertz, like 550 megahertz, and now in 6 gigahertz is another 1200 coming, it is a huge opportunity. We know that the current, let's say, unlicensed technologies cannot meet the demand, let's say the requirements of the industrial cases. So we have solutions like in MFA, we have derived MultFire for unlicensed band in the 5 gigahertz, and now the new radio unlicensed is coming from 3GPP, which is also technology which is evolved from that perspective. So we do have an umbrella of unlicensed and locally licensed spectrum, which is dedicated in this respect for the enterprises, for the verticals. And that will really mean that we can really design the system in such a way that it will be much meeting all the demands and all the needs of the enterprises and our customers. Back to you, Catherine.
Great. Thank you, Makis. So Steve, Inseego sells modems, gateways, and routers into a number of verticals, including, of course, manufacturing. So earlier this year, the company announced a 5G gateway designed specifically for industrial and IoT use cases. Why does manufacturing or industrial environments, why do they require such a specially designed connectivity solution? And how are such solutions being designed today?
Thank you for that question, Catherine. And again, it's my pleasure to be here with these fine folks. I think the reasons you've heard articulated by each of these gentlemen, number one, speed and latency is critical in these manufacturing applications. Flexibility is another reason because we don't really know ultimately what customers want to go and measure, how they want to measure it. So you need to have a flexible architecture to be deployed that's 5G capable to deliver the ultra low latency, the ultra wide bandwidth, the security, and the management across a private network to be able to deliver the results that a private network or a public network is going to give you. Manufacturing, just from an environmental perspective, there's different types of manufacturing. There's chemical manufacturing, there's automotive manufacturing. You have to be thinking about these types of things because you can't just stick an off-the-shelf piece of gear in there because is it spark resistant? Can it be battery powered? And what are you connecting to? So Inseego has spent the bulk of our history working with public operators to develop 2G, 3G, 4G, and now 5G capability on the network side. But as important as that is, I think Makis was hitting on a couple of key points. The customer is way more sophisticated today, and they're going to want to take on more of that responsibility to manage those networks for lots of reasons. Speed to deploy the network, security is paramount within these environments, and they want to be able to manage that ecosystem a little better because I can't remember who said it, but it was a great point. There is no one size fits all. There's network, there's infrastructure, then there's application, which really pulls the data together in a meaningful way. Because I don't know about you guys, but none of my customers are asking me for more data. They're asking me, what do I do with this stuff that I've got, and how can I categorize it in a way that's meaningful? As we've evolved over the years with analytics, it's been first was kind of hindsight. You would collect all the data, you would look at it, and you would go, oh, okay, well, we've learned this. We moved to where we could get insights from data. It got a little bit more real time. Now, with purpose-built devices that are meant to go in and serve in these environments, not only can you get the data that you want, because what 5G's done is it's really removed the final barrier of that quote unquote last mile. Because if you take a typical deployment of say 4G, a typical 4G radio in a square kilometer, you could only connect about 100,000 devices. Well, that same radio footprint, you can connect over 1 million devices on a 5G network. So now if you start to think about a manufacturing floor facility, there's going to be tens of thousands of devices connected. So you have to be able to incorporate all that into a meaningful way. So now it's foresight, using these types of capabilities for digital twinning to learn, on a digital twin versus blowing up one of your real engines out there trying to prove a use case or learn some efficiencies. But I think it's key to be very intimate with your customers today. You have to be out there working with them to understand what outcomes they're trying to get to before we prescribe any solution. So we spent quite a bit of time talking to our key clients and potential clients around what do we need to connect? What are the things, in the short term, medium term, and long term you're going to want to be able to do? So, as we see the typical things like robots and machines and others to gather that data from either a preventative or predictive maintenance, there's things like video. Now, video is highly intelligent and can be deployed across a floor to really gain. It's the new sensor. So you have to be able to support these next generation technologies with an open platform. And that's the approach that Inseego took.
Thank you. And let's zero in on the use case of automation. I know we've talked a lot about a bunch of different use cases, but let's talk about this one in particular because it kind of comes up a lot. So Abellatif, when it comes to automation, whether that's factory automation, process automation, monitoring, or predictive maintenance automation, we keep hearing that 5G will make a big difference here. So what's your perspective on how 5G will improve and accelerate automation in the manufacturing space?
Yeah, thank you, Catherine, for the question. And I think that a lot of things have been said for on this perspective, and especially Steve have just mentioned a lot of things about data in different forms, especially video, and also the whole intelligence behind to process these data. So for me, automation, or in general, automation in manufacturing is mainly about data, and all the use cases are based on that. And collecting data in its different forms, including immersive one and video, using big number of devices and sensors with low latency, with security, reliability, is really important for automation. And 5G is the underlying connectivity enabler to do that, because without 5G, you cannot do that. So 5G is kind of, I would say, a deadlock breaker in order to use other technologies like artificial intelligence and others like AR, VR to build solutions for manufacturing automation. But let me bring it more concrete, because within the industrial 5G testbed and trial program, we have done the right way to show that. In most of the projects, the use cases were firstly implemented over a 4G network, and that was the baseline from which we measure and show what 5G can bring. So this is the baseline, and after that, the projects implemented these use cases over the 5G network, standalone or others. And what we have seen that without 5G, most of the projects cannot be really function or work in the right way, and we cannot take advantage of them if we don't have 5G connectivity. So for example, some solutions worked with 4G, but in limited scale, and needed 5G to scale up and be used in large area. Also, quality of experience, especially for VR, AR use cases, you don't have the real quality of experience that can make these use cases and application gaining acceptance from the users and be used in the manufacturing floor. Security is very important, and especially when we talk about data collected within the manufacturing, that is critical and should be not go out of the manufacturing perimeters. So this is important, and 5G give these capabilities and give security, a lot of security and confidence and trust. So make these solutions more acceptable within the manufacturing ecosystem. So I would say that it's mainly, as I mentioned, it's deadlock breaker to bring other solutions based on other technologies in combination of other technologies like AI, VR, AR and VR and others. So this is mainly the key point, but let me also bring kind of parallel with what we know in the 4G era and also consumer markets. 4G has really unlocked the usage of smartphones and applications in the consumer markets. So if we have our smartphones today is mainly, and all the applications we enjoy, it's because we have good connectivity, 4G, even sometimes we don't think about it. And also we have big companies and services like Uber because we have this connectivity. And for me, 5G is for the industrial and the industry and manufacturing logistic verticals is what is 4G for the consumer markets. So in a nutshell, if I have to respond in one sentence to your question about the improvement, so how 5G will accelerate automation in manufacturing, is mainly being kind of a platform, 5G as platform for innovation, low level in sense in giving all the enabling connectivity for all the upper technologies to build the right solutions for manufacturing. So this is the key point.
Thank you so much. So my next question is for Makis, but I'm also going to get Andreas's perspective on it as well, because in a previous interview, Makis, you said that industrial users do not necessarily know what they want from 5G devices or from 5G in general. You said, quote, industrial users can tell you what they need, what the solution has to do, but they're not much good at translating all of that into telecoms language. Would you say that this communications gap is the biggest or one of the biggest hurdles when it comes to 5G in manufacturing? And if so, how can this be overcome from your perspective?
Yeah, thanks, Catherine. This is an interesting point. Enterprises, of course, understand the importance of 5G, and they know what they need it for, to use better automation so that they can really save money and make it more efficient for their work. So they need more reliable communication. They understand that the current, let's say, solutions cannot offer what they need. But there are points like they understand the high level things, like they know the data rates, the latency, they know the uplink. The uplink is a very important part because many of the devices like cameras, they need to transmit quite a lot of data that they need to securely and fastly go to the point of process. So that needs to be taken into account. So the high level requirements are known. Now, if you look at 3GPP, release 15, it has about 400 features. And we're talking about like CQI, modulation coding, hard arc, repetition, mini slot, and so on. There are families of features that they really make the standard work. And now, if you, from one end is the high level requirements, from the other end are all these technical features. And I think there is a gap here. And the gap here between the industry and these features is what is the problem. If you ask the MNOs, if you ask the CSPs today, they know about it immediately and they can answer what features you can deploy in your consumer type of smartphones or whatever, because they are part of 3GPP. They are part of 3GPP a long time. So they understand when they develop the standard together with the vendors, with the chipset manufacturers and so on, they know what priorities they want for this feature. So they say, this is priority 1, 2, 3, 4, and so on. But if you go, on the other hand, to the verticals, to the industrial players, hopefully now they started participating also in 3GPP, but there is a gap. So they do not exactly know how to match this type of requirements, high-level requirements to the features. And now that is where the MFA is going to fill this gap. We're trying to create what we call Uni 5G blueprints, So this will be more or less a guideline to the chipset vendors and the device makers to correctly, or let's say to prioritize the different features so that it matches the requirements of the industrial cases. So you would have, let's say, different class of devices that would need, let's say, for the ports or for mining or for airports and so on. And then these devices will have a certain set of features that are addressed from 3GPP, because 3GPP, again, it's optional features, so it is not mandatory, but it will be a guideline from the vendors to say, yes, if I want to make a device which is very suitable for logistics, and I want this kind of high level type of requirements, what should I implement? And then you can have 1, 2, 3, 4, 5, and then you go on, and then you create this guideline. So that is what we are trying to do in MFA right now. And we have learned this from the ecosystem in the first phase when we built MultFire, because the question always in MultFire was, how many million devices do you want? And then you say, well, we're starting only now. We have industrial cases, so we're talking about a couple of thousand of them, and then no chipset vendor will sit down and make it for you. Because they prioritize, of course, the smartphone devices that are in millions in the consumer market. But now this hopefully will change. And with the 5G and the new radio unlicensed and the 5G technology, we hope that we'll have more, let's say, a rounder approach with the industry supporting that we identify these priorities that will need it to be made in devices so that we have the ecosystem together. So yes, it is a communication problem, but it is also because the starting point is different. We have, from industrial point of view, we have to get into the game, which is already in some speed, and there is traction, which is from the consumer market, and we really need to catch up. But I hope that will be in 5G, it will happen. Thank you, Catherine.
Thank you. So we don't have a lot of time left, but Andreas, can you offer kind of the manufacturer's perspective on this issue? What are they looking for when they sit down with the vendor?
Yeah, no, I mean, I basically can agree. So there is certainly, that's a challenge, right, to bridge the gap between the ICT industry and the OT industry. So that's really one of the key challenges. And it starts with speaking the same language. And I'm not so much thinking about the syntax, more about the semantics, so that you really know what you're talking about, right? So sometimes you think you know what you're talking about, but from my own experience, I can tell then after some time, you figure out, okay, we had completely different things in mind. It starts with the latency, right, which can be completely different depending on whether you're talking to a radio guy or to a industrial automation expert, which maybe thinks more in terms of a cycle time than in terms of a radio latency and so on. So really, these things are very important. And it was, I mean, of course, this to build or to bridge this gap, this was also one of the main triggers for establishing 5G ACIA 3.5 years ago. And I think a key challenge is that a manufacturer is not really interested in 5G per se, right? The manufacturer has a problem and is looking for a solution for his problem. And 5G may play an important role here in future, but 5G alone does not provide any value. So it's always important to look at a complete use case where 5G can be a part of. And I think in order to really find the interesting use cases, we need a holistic understanding. That means the OT side needs to better understand the 5G capabilities and so on. And the ICT side, likewise, is to get a better understanding of the OT side, because it's really the sweet spots are not just by, you don't get this by replacing a cable using 5G or by replacing Wi-Fi with 5G. These are the things that typically come first to your mind if you talk to a manufacturer, right? But it's really getting interesting if you really rethink the way you build a system, if you change the system architecture, if you start offloading intelligence from a device, from an automated guided vehicle to a local cloud, for example, and then close the control loop over the air. But this is then not the evolutionary step is then really more a revolutionary step. And this requires really this holistic understanding. So that's why this dialogue between the OC industry and the ICT industry is very important, to really think in use cases, not just in terms of providing a technology, and also take it even beyond the use case in terms of a business case, right? So that you can really carve out the value add that 5G brings. Because if I replace Wi-Fi with 5G, maybe I can do it better. But the question is, okay, what is this really worth money-wise? So how much can I save? How much more efficient can I make the solution, and so on? And that's really anything but trivial. And maybe the last point to mention is also from a business point of view, right? There needs to be somehow some alignment between the ICT industry and the OT industry. If you look at a mobile network operator, for example, traditionally they are doing a B2C business. But of course, if you look at using 5G manufacturing, it's more about B2B. That means we need new charging models, liability plays a more important role, and so on. Also, you want to have 24/7 support and things like this. And also, this is something where we have to find an alignment between the different camps to really come up with good solutions at the end. I think I'm running out of time.
Yes, we have to unfortunately end there. We're a little bit over time. I know it's a big topic. Thank you all for tuning in, and make sure to check out our next session, Making Sense of IoT, AI, and Machine Learning for Your Business. Thank you.
Thank you.